Hello everyone, welcome. Welcome to a journey through the digital wilderness where algorithms evolve, adapt, and conquer challenges with the tenacity of nature itself. Today, we are venturing into the heart of genetic algorithms, a realm where bits and bytes mingle with DNA and form solutions to the crucible of computational evolution. Imagine a world where problems were never solved, but conquered through the relentless process of digital Darwinism. Genetic algorithms are the architects of this brave new world, sculpting optimal solution from the raw clay of possibilities. So strap in and prepare to witness the magic of evolution unfold before your very eyes. From optimizing supply chain to crafting the perfect travel itinerary, genetic algorithms are the digital artisans shaping our future. Myself, Rohit Gowda. I'm studying in Sri Venkateswara College of Engineering. Today, I'm discussing genetic algorithm. Join me as we embark on an odyssey through the evolutionary wonders of genetic algorithms, where every solution is a testament to power of adaptation and innovation. Let's begin. Genetic algorithm is a search-based optimization technique based on a principle of genetics and natural selection. It is frequently used in finding optimal and near optimal solutions to difficult problems which are otherwise would take a lifetime to solve. Nature has always been a great source of inspiration to all mankind. Genetic algorithms are such based algorithms based on concept of natural selection and genetics. Genetic algorithms are based on the principles of selections, crossover and mutation. A basic terminology: population. A population is a subset of possible solutions to a driven problem. This is what a population is. A chromosome. It is a chromosome. Chromosome can also be called a genotype. You all know what genotype is. Genotype. It is a chromosome, one of the solution to given problem, the tiny solution which adds on to problem solving. Gene. It is one of the element position of a particular chromosome. So here you can have a look at a small block diagram which shows genetic algorithm. This is the genetic algorithm usually starts from population initialization. So you initialize the population and you check the fitness calculation of the population. Then you cross over, then you induce a little bit of mutation, then you do another selection where you check for the survivors and loop until terminate criteria reached. So you set a criteria for the termination of the loop to check the survivability. Then you loop it until it terminates the criteria reached. Then terminate and return the best. So this is the basic working of genetic algorithm. So taking a real world example, suppose you can take optimizing energy distribution networks. Imagine you're tasked with designing an energy distribution network for a rapidly growing city like Bangalore, where the goal is to minimize energy loss while ensuring reliable power supply to all residents and businesses. This is a complex optimization problem with numerous variables, including the location of the power stations, the layout of transmission lines, and the allocation of resources. Take a scenario: designing the future of energy distribution. In our scenario, let's consider the city of metropolis, a bursting metropolis facing exponential growth in energy demand. The city planners are tasked with revamping the energy distribution network to accommodate this surge while minimizing costs and environmental impact. Here enters genetic algorithm as the architects of the change. The process begins by representing potential solutions as chromosomes, each encoding a unique configuration of power station, transmission lines, and distribution centers. These solutions undergo a process of evolution where the fitness individuals, those with the lowest energy loss and highest reliability, are selected for reproduction. Through crossover and mutation, new solutions emerge, combining the most promising traits of their predecessors, that is, the parents, over the successive generation. The population converges towards the optimal or near optimal solution, configurating to the most optimal solution, balancing the trade off between efficiency, cost effectiveness, and resilience. This is how the basic genetic algorithm works. Eventually, the genetic algorithm unveils a blueprint for the future, a decentralized energy grid that harnesses renewable resources, minimizes transmission loss, adapts dynamically to changing demand patterns. The city of Metropolis embark on the transformative journey towards a sustainable and resilient energy future, which is empowered by the ingenuity of genetic algorithm. From optimizing energy distribution networks to revolutionizing urban planning, genetic algorithms are the architects of change, shaping the cities of tomorrow with the precision of digital evolution. This example illustrates how genetic algorithms can tackle complex optimization problems. So, moving on, population initialization. So, now I'll take a real world example and explain how genetic algorithm works. So, take take another example of designing aircraft wings. Imagine you're an aerospace engineer tasked with designing the most efficient aircraft wing for a new passenger jet. The challenges here is to optimize the wing shape to minimize drag while maximizing lift, ensuring fuel efficiency and safe operation at various speeds and altitudes. So you have to minimize drag and ensure maximum lift. So how genetic algorithm works? It works from this first step which is called initialization. The process begins by creating an initial population of potential wing designs. So you take all the wing designs possible, and each design is represented as a chromosome, encoding parameters such as wing shape, size, and curvature. Then comes the second step called evaluation. Here, the fitness of each wing design, that is the individual designs you added as an individual chromosomes, are evaluated using computational fluid dynamics, which is a simulations or a simulators. These simulations analyze how airflow over the wing, calculative lift and drag forces. So this is how fitness evaluation is done. So moving on to the next step comes selection. Selection, wings with higher fitness values, for example wings which produce more lift and less drag, are selected for reproduction because they are considered superior. This mimics the concept of survival of the fittest, which is also called natural selection, where the most fittest animal tends to survive and is moved on to the next generation. So this is where the selection process occurs. So next step is crossover. Crossover is a genetic operator that combines genetic information from two parents solutions to create a new offspring. So you selected few wing designs which undergo crossover, where genetic material, those are design parameters, that is which are inside the chromosomes, is exchanged between pair of wings. This introduces new combinations of features, potentially leading to a better performing offsprings. So this is the fourth step. Coming to the fifth step. Occasionally, mutation is genetic operator that introduces random change in offspring's genetic material. Why you introduce mutation is because to get desired change in the future offsprings. So your occasionally random changes, mutations are introduced into the genetic material of the wing designs. This adds diversity to the population and prevents premature convergence to suboptimal solutions. So the final step is termination or reproduction, where the new population is then evaluated using the fitness function to determine the next generation's quality. So this process continues iteratively for multiple generations, with each new generation producing wing designs that are incrementally better adapted to their environment. The algorithm terminates when the satisfactory wing design is found or after the predefined number of generations. So the process continues until a satisfactory wing design is achieved, balancing lift, drag, and other parameters criteria. So this is how genetic algorithm works. So what are the advantages of genetic algorithm? It does not require any derivative function. It's faster, more efficient as compared to traditional methods. Has a very good parallel capabilities. Optimize both continuous, discrete functions and also multi-objective problems. Provides a list of good solutions, not just single solutions. It provides multiple solutions which are again selected during termination. What are the disadvantages of genetic algorithms? Genetic algorithms are not suitable for all problems, especially problems which are simple, for which our derivatives information is always available. Fitness value is calculated repeatedly, which might be computationally expensive for some problems. There are no guarantees on optimality or the quality of the solution. So you cannot guarantee the optimality and the quality of the solution all the time. if start implemented properly, the genetic algorithm may not converge to an optimal solution. So these are the disadvantages of genetic algorithm. Coming to application, genetic algorithms are used in various fields, including optimization, machine learning, and computer science. They're applied in problems like scheduling, routing, machine learning model, optimization, game playing, etc. Genetic algorithms can find solutions in complex problems where traditional optimization techniques fail to do so. So coming to conclusion, this is about genetic algorithm, which are most powerful optimization techniques inspired by the principle of